all about linear equations. So a couple key characteristics of linear equations. What will the shape of the graph always be for linear equations?
A line.
What type of line? Straight, curvy?
A straight line.
Straight line, good. And it will always, so the shape is a straight line. And it will go on forever in both directions. Why is my, there we go. Okay, it will go on forever in both directions. Go on forever. We had talked about, so let's look at this example here on 4. We should have, you will always see arrows on both ends to show that it's going on forever and ever and ever in both directions. Okay, straight line. And your domain here is all real numbers, meaning every x value will exist on the graph. Every x value will be solutions. And then that also means for your range means every y value also exists. So your domain and your range is all real numbers. Really important to keep that in mind. I don't know why it won't let me bullet. There we go. All right, any questions about those points before we get started? So we want to keep those in mind as we go. So on this problem right here, number 4, notice we have a straight line. 2 of the coordinate pairs are highlighted. That doesn't mean that these are the only 2 coordinate pairs that exist on this line. We can find other coordinate pairs by seeing where the line crosses perfectly to other coordinate pairs. So possibly here, possibly here. Looks like those could also be more coordinate pairs. Okay, this one is all about slope, lesson 4.1. So slope is steepness. Here's a couple different ways to think of it. You can think of it as rise over run. You could also think of it as y2 minus y1 over x2 minus x1. How are these expressions written here? What do you notice? Written as fractions. We always want to leave our slope written as a fraction, unless it's a whole number. So you could write it as a whole number or a fraction. Don't you dare give me a decimal if I ask for a slope. Okay. Go ahead, put your hands up. I solemnly swear to not write slopes as decimals for the rest of my mathematical career. Go ahead. Okay, good enough. I hope your parents heard that. All right, here we go. Let's find the slope of number 4. Who wants to do 4? Who wants to do 6? Okay, Malachi just claimed 6. All right, go ahead and show your work. How are you going to find the rise and how are you going to find the run there for your slopes? Go ahead and make those slides messy with your work. Oh, Fergus, what are you doing? I'm sorry, guys. There we go.
Mom, there's someone else.
Good. So Caden, let's find the rise between the 2 points that we know. They gave us 2 points. So over 2, down 4. And this one is at, there we go, good. So what's your rise there? How many are you going up from one to the other? It's 1 box, but pay attention to your scale there. You can look at the y coordinates. So how far apart is -6 and -4 from each other? How many units there? Okay, Malachi, I'll write your rise and your run here for you so you can just fill in the blank. Is that helpful? There we go. Good, so you can count, good. And how far apart side to side? So we're going from -4 up to 2, good. And they are 6 units apart, all right. So go ahead and reduce that, Caden, to 6 is equal to both of those are divisible by 2. So we can do, there you go. Good work. Malachi, how you doing on rise and run here? So rise is our 12 minus 3. Our run is our 4 minus 1. I wonder if something happened to Malachi. All right. So 12 minus 3 is going to be 9. Oops. Four minus 3 is not 3. 4 minus 1, excuse me, is 3. 9 divided by 3 is 3. So our slope for that line is 3. And I wrote m equals 3 because as we go through this unit, anywhere you see m, it denotes slope, just holding in place. So you can write it as 3, 3 over 1, whatever floats your boat. But definitely fractions will not float your boat. Fractions will, or excuse me, decimals will make your boat sink, your slope boat. All right, let's look at number 9. So same exact thing, except this time we don't have a graph. So how are we going to find slope if we don't have a graph? You could graph if you wanted to. It's a great problem solving method. Or we can fall back on an equation. And so look back to what we did here with our x and y values on number 6. To find our rise, we subtract our y values. To find our run, we subtract or find the difference between our x values. Here is the formula up here on the top of your page, and I pulled this right off of your worksheets in Apex. So we're going to subtract our y values from each other and divide it by the difference of our x values. Nice. Love seeing all that work shown there. All right. So, party people, let's label. Let's call this x1 and y1. And that second coordinate pair is x2 and y2. Nice, love those labels. Okay. Where is my, there you are. So rise is going to be y2 minus y1. So 7 minus -14. If you did -14 minus 7, that's great too. Your x values are also going to be reversed then. So -3 minus 25. Good. So Malachi, keep going the way that you are. Okay, so Malachi, you're doing 14. You're doing negative 14 minus 7, yes? So then you need to also start with the x value of 25. Notice how your negative 14 is from this first coordinate pair? Okay, so since you started with 14 here, this leading value in your run also needs to be from this first coordinate pair. You just have to stay consistent. Good catch. All right, so I'm going to add the opposite to simplify these. Hi, Katie. So 21 divided by negative 3 minus 25 is a negative 28. We're finding slope on number 9 down there at the bottom, Katie. Okay, Caden, look at what we have here for our fraction. For our slope, 21 divided by negative 28. Can we simplify that? Is there a number that goes into both of those? Yeah, I agree. 7 goes into both. So we're going to be left with 21 divided by 7 is 3. 28 divided by 7 is 4. And we still need that negative. We need a negative for our slope. So these points are on a line where our slope is negative 3 over 4. Negative 3 over 4. Good. Okay, what questions do we have on that one? So if you're rusty on these, you need to go back to 4.1. And especially if number 9 was challenging, where you're finding the slope just with these coordinate pairs, find more problems that are like that to practice, okay? So these were from the checkup worksheet. So there are more of these on that checkup worksheet. Okay, write yourself a note if you need to review those. All right, Katie, are you reclaiming your turquoise? I'll get off your blue. So you can do it if you would like.
You can still use blue.
All right, you'll just do turquoise. All right, okay. Let's look at the next lesson, which is all about slope-intercept form. So this unit talks about 2 different forms of equations, and each one has some special characteristics. You can write a linear equation in both forms, okay? But sometimes you're going to want to use one form over the other. Sometimes one form is not helpful at all. So let's look at slope-intercept form. Here it is. I pulled this right off of your, oh, Fergus, you're wayward clicking. All right. I pulled this right off of your study guide again. Whenever you see a linear equation that is solved for y, it is in slope-intercept form. But the key is it has to be solved for y. Y has to be alone on one side of your equal sign. That's the tricky part. But when that happens, your value in front of the x is your what? Our m is always going to be our slope. Good. And our value added to the end, our b value, stands for the y coordinate of the
Y-intercept.
beautiful. Okay. Reminder, y-intercept is where your graph crosses the y-axis. This is your y-intercept. Beautiful, okay? On this one, oh, Katie, do you want me to send the document? Are you able to print it off real quick, or do you want it? Or are you okay doing hand notes?
I'm okay doing hand notes.
Okay. So really important with slope-intercept form, that you have solved for y. And I'm even going to write that down because it's so important. Solve for y. Like if you were going to get a tattoo of slope-intercept form, you should even put down solve for y like under it because it's so important. Okay. All right. Love it. All right, let's graph. Katie is ready to go. She said that negative out in front means it's decreasing. Good, Katie, because that -2 is your what?
Slope.
It is our slope. And we know that because this equation here is solved for y. So you want to look at the equation you're working at and try to recognize the form. We have y by itself, so we know this is slope-intercept form, slope-intercept form. There should be sirens going off in your brain. Wee, 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 slope-intercept form. All right, let's graph it then. It'll be really easy to graph when we have slope-intercept form. So you start with your y-intercept.
Wouldn't it be a -1 since it's take away?
Good. So your y-intercept, look it over here, is the number added to the end. So if we have a -1 over here, that means yes, our y-intercept is at -1. So that is the first point that goes on your graph, down there at -1. And on your graph, actually label that that is your B, or your y-intercept. Why does my coordinate pair keep deleting? There we go. All right, once you know one point on your line, if you know your slope, you are golden. Golden. So we know a point on our line. We know our slope is, oh my goodness, coordinate pair keeps deleting for me. Hopefully someone else can make a coordinate pair there. All right, really important here that you think of slope as a fraction. So if our slope is -2, that is equal to -2 over 1. Really important you think of it as a fraction, so we have our up and down movement and our side to side movement. So we have our up and down and our side to side, our rise and our run. Beautiful. So from that coordinate pair, why does my y-intercept keep deleting? Oh my gosh. Okay, good. So from my coordinate pair, I'm going to go down 2 and I'm going to go to the right one. So I'm going to go down 2 to the right one. And that is another coordinate pair on our graph. And then I'm going to do it again. I'm going to go down 2. Oh my goodness. Over 1. It's like a Cam Jansen book, Case of the Disappearing Coordinate Pair. There we go. Thank you for writing that in. Good. So there's our coordinate pairs below to the right. How could we find the ones to the left? Let's go back up to our y-intercept. So we know our coordinate pairs are going to stay in a straight line. So just reverse your pattern and go ahead and draw in some coordinate pairs. Good. Okay. This is built-in process to verify your work. If your coordinate pairs aren't in a straight line, that's feedback for you that something's fishy, right? Because we started by talking about your linear equations as a straight line, always. All right, beautiful straight line drawing through there. It's not just coordinate pairs, it's all the mini coordinate pairs in between, all the dirty decimals. And what should be on each end, guys? There should be some fancy decorations on both endpoints.
I put them on.
Beautiful. Arrows on both sides because it goes forever in both directions. So when I ask you to graph, or you see in an assessment that you're asked to graph, I am looking for a straight line. I'm looking for coordinate pairs darkened on your line, and I'm looking for arrows on both ends. Okay. All right, what questions do we have on that? Okay, so we just did a process going one way, the neuron pathways in your brain. Now we're going to reverse that process. So now we're starting with the graph and we want to go backwards to the slope-intercept form. So go ahead and you guys can do it on your own paper or you can do it on the screen. Go ahead and now find the equation of the line. Y equals mx plus b. We need our slope and we need our y-intercept. Go ahead and just substitute that information in. Okay, Malachi and Katie, you guys said the y-intercept is 4. How come?
Because on the line intercepts with a y-axis on the point 0, 4, and the y coordinate for it is 4.
Good. So our y-intercept is up there at 4 crosses. Right up here at 4. Beautiful. Okay, so now we just need our slope. Honey, why did you just unplug this? It's not funny. Okay, so how are we going to find our slope now? We need to find our m value. So our rise divided by our run. All right, Katie, I see you threw in -1/2. So from one coordinate pair, we went down 1, good, and over 2? Good, Malachi, I see your drawing is in there, down 1 over 2, okay. So rise over run, and notice our line is going decreasing from right to left. That means our overall slope is a negative. Beautiful. Good, Caden's putting it in too. Beautiful. Okay, which of these was more challenging for you guys? The first one or the second one? First one where you have to graph, or the second one where you're writing the equation? Which one was more
They were
challenging?
both about the same for me, but maybe the first one.
Okay, let's move to the next. And I'm going to erase your drawings. Okay, here we go. So still slope-intercept form. And the name of the game here is that we are graphing. So we want to graph. And after you graph, identify 3 coordinate pairs on each line. Should we, let's see, what color is someone not using? Should we do orange? Okay, so this first one, let's graph it in orange together. That way we can do it on the same graph, and nobody is using, yellow is too hard on the eyes. Here, let's use red to do the second one, even though I'm using red. Okay. So let's look at this first one here. So the orange line. Question, is this in slope-intercept form? Are we able to graph this right away? Reminder, we have to have y by itself. Is y by itself in this equation?
No,
Y is not alone yet on one side of the equation. So that's the first thing we have to do. So step one, in order to graph, we need to put it in slope-intercept form. As soon as we do, we're able to see what the y-intercept is and the slope, and then we're able to graph. So we're first going to put in slope-intercept form, and then we'll be able to graph using M and B. All right, so let's do that on orange. I spy on the left side of the equation a negative 2/5 x. How can we move that negative 2/5 x to the other side? Good, Caden wrote in, we're going to add 2/5 x to both sides. Beautiful. So we are left with y equals, yay, jump up and down. All right, are we able to combine 4 and 2/5 x? Or 4 and 2/5 x on the right side there, are they like terms? Yay or nay? So we just have to write it out. So go ahead and write 4 plus 2/5 x. Okay, only now, because we've solved for y, are we able to identify our slope and our y-intercept. So go ahead and label that in our equation. Good job working together, guys. So the 4 is our what? And the 2/5 is our what? Good, slope is 2/5. Is it a positive or a negative 2/5? And that 4 is our what? 4 is the y-intercept. Good work. Okay, so when we're graphing, we first start with the y-intercept. We have to start with a coordinate pair that we know. And so we know this coordinate pair. So we're going to start here with that 4. So on your graph, you're going to go up 4. 1, 2, 3, 4. Okay. I hope that that coordinate pair does not disappear. All right, someone draw over it for me so it doesn't disappear. So that's our B, our y-intercept right there. Okay, from there, we're going to use our slope and we're going to find more coordinate pairs. Our slope is already written as a fraction. Yay, less work for us. So we're going to go up 2 and to the right 5. Up 2 to the right 5. So someone go to the right, someone go to the left. Instead of going up 2 to the right 5 to find more coordinate pairs, we could go down 2 to the left 5. So go ahead and draw in coordinate pairs. And that line, when we get it drawn in, needs to be done in orange, remember, please. Nice, Malachi, I like your coordinate pairs. All right, up 2 to the right 5, 1, 2, 3, 4, 5. If you don't have a ruler at home to do your graphs, that's fine. I use pieces of paper folded to make straight lines. So I just take a sheet of paper, look at all my scratch paper, and I fold it again to make a really good strong edge. And then I can connect lines or connect coordinate pairs. All right, and let's see, I want to also see what on both endpoints. Beautiful linear line through all that. Seamus, please stop. And we need arrows on both ends. Beautiful. All right, and it's orange. Good. Okay, so our takeaways from that one were, in order to graph, we have to have our line in slope-intercept form. Okay, all right, now let's look at the red. Is this in a form where we can easily graph it? Not yet. So we have to get y by itself. Before we start moving things, let's try and think smarter and not work harder. So let's talk first. If we subtract 5x over to the other side, it disappears. But then what are we left with? We're still left with a negative y. Negative y is not the same thing as positive y. So I would still have some more work to do to get y by itself because it wouldn't be alone yet. So right now I have a minus y. What if I added y to both sides? What will happen? Negative y plus y goes away. And now it's moved to the right side. And notice now it's positive, which is what we want. But then I have to get rid of this 2. Yep, so then we can subtract 2 from both sides. Nice. So 2 minus 5x. Okay. I'm going to challenge you here. Is your 5x over here positive or negative? What's the sign in front of your 5x? 5x should be positive. So check in your equation that 5x is positive. And the 2 is negative. Okay, girls, what do you think about that? Are you okay with manipulating that equation with your signs and everything?
Yeah, I kind of lost track a little bit because I had to take my headphones off to get a pencil.
Okay. So we added y to both sides, and then we subtracted 2 from both sides. And we moved the y over to the right side because when we left it on the left side, it was a negative y. And that is not solving for slope-intercept form because we need a positive y. Okay.
I keep on getting this confused with the point slope equation.
Yes, yep, and it happens. So really important here, when you are graphing, slope-intercept form is the best form to use. So write yourself a note. Slope-intercept form for graphing is the best one because you can instantly see your y-intercept and your slope.
Oops.
Okay. So let's go ahead and finish graphing then. So we have our equation is in slope-intercept form. So that -2 is our b, and that 5 is our m, or our slope. All right, so we're using red on this one, so please use red on the graph. So b is our y-intercept. So our graph is going to cross the y-axis at -2. Nice. Okay, our slope is 5. How can we rewrite that so we can see the rise and the run? Nice. So we're going to go up 5 over 1. Gosh, you guys are on it. All right, so someone please go to the right to find the next coordinate pair. Someone go to the left of our y-intercept to find some more coordinate pairs. Nice. 1, 2, 3, 4, 5. Good, you guys are fast. All right, throw in that straight line. And what's going to go on both ends? Beautiful. Get that straight line. You guys are getting good with the annotate functions. And arrows on both ends. Beautiful. Good. Caden extended it a little bit, making sure it's done. Good. POTB, you guys. Pat on the back. You did it. Good. Okay. The more you practice this, the faster it will get. Okay. That's where your fluency comes into play. That's where those Apex worksheets come into play. Really important that you're doing those. Before we move on, the things to make sure that you have written down in your notes is that to graph, it's easiest to have your equation in slope-intercept form. Slope-intercept form. Y equals mx plus b. Okay, you ready? Okay, I'm gonna fast. Okay, you're done? Okay, here we go. Let me clear the drawings. All right. Here's the other form of linear equations that Malachi, was that you that was saying you get point slope equation mixed up with slope intercept equation? It's quite a mouthful. Okay. So point slope equation. Good, go ahead. M is the same. Yep. M is holding the place for slope. All right, and this x1, y1 is a coordinate pair on the line. Any coordinate pair on the line. So think back to our slope-intercept form. We needed a y-intercept. We needed to know where it crossed the y-axis in order to use slope-intercept form. Here, we need just any coordinate pair on our line, and we're able to use point-slope form. So if we know the slope and 1 point on our line, we're good to go. Okay, let's go ahead now and fill in that chart on number 2. Let's do this first one together here. So our slope is our number in front of our parentheses here in point slope form. So our slope here is 3 for this first one. And a point on our line, our x coordinate is in the same set of parentheses as the x. Our y coordinate is being subtracted from our y in our equation. So this is our x coordinate, and this is our y coordinate. There we go, good. A 5 and a 6, good. All right, this next one down, our slope, -9, nice find. Okay, point on our line, make sure you have it in coordinate pair form. So it's the opposite. Nice catch. Our x value is the opposite. Good. -8. And our y coordinate is 4. Beautiful. Good. All right, and then we'll talk about that third one down when Malachi is done with. Okay. Oh, good. So Katie, you put in 5 for your slope. Now notice with this one, we don't have a set of parentheses with something added or subtracted, do we? So because we don't see a number added or subtracted, that means we have a 0 being added or subtracted, which means that x coordinate of that coordinate pair is 0. Good. Good catch. Okay, so at this point in my math career, I was like, why are we having to learn more than one form of linear equations? It's overkill, it's unnecessary, okay? It's because you're not always going to be given the same information about a line. So you use point slope form when you know any point on your line in the slope. You can only use slope intercept form when you know your y-intercept and your slope. That's the difference between them. One equation doesn't do everything, okay? So let's see how we could use both equations though when we have a graph of our line. So let's look at 7. write a point slope equation and the slope intercept equation for the line below. So for our slope intercept equation, this is where we run into trouble. So say all we knew was slope intercept form. So the first thing you would want to do to write this form of equation would be to find your y-intercept, where your graph crosses the y-axis. Look at, and it looks like it's crossing in between 0 and -1, right? Do we know exactly where? Like, can we tell with 100% validity, certainty, where it is? No, we can estimate it, but we don't know exactly. So for slope intercept form, we're unable just to pull that y-intercept off. So that's when we can fall back on point slope equation. So let's go ahead and write it in. So we're going to have y minus y1 equals m times x minus x1. Okay, which coordinate pair do you guys want to use for our graph? It doesn't matter which one. We have two here that are marked. You want to use this one? I like that one. Why did you guys go to that one? 2, 1.
It's easier because it's not negatives.
It's
Good.
a positive.
Good. There's no negatives. So if at all you can avoid using negatives, do it. So if -2, -2 was the only coordinate pair given to us, we would have to use that, right? Okay. But yay, we have options. Okay. So go ahead and substitute in your information. So our x is going to be 2, our y is going to be 1. Good. So x minus 2. Beautiful. Y minus 1. Good. Okay. How are we going to find our slope? Our m. Do we know 2 points on our line?
Yeah.
All right. Giddy up. Go and find your rise and your run. So our rise looks like we're going from -2 up to 1, which is 3 units apart. Nice, Katie. Good. So up 3. Okay, and our rise, good. Our run is 4. Okay. So when I use the equation, I got a -3 divided by -4, which is the same thing as +3 over +4. So notice we get the same thing. Beautiful. Okay, so our equation is, I'm just going to write it in one color so we can see, is y minus 1 equals 3/4 times x minus 2. Okay, that is our equation in point slope form. Okay, now how would I find, once I know my point slope form, how would I find my slope intercept form? What was that other piece of your tattoo, your slope intercept form tattoo? It said solve for y. Solve for y. So if we solve this equation for y, we have our slope intercept form. So let's solve this equation for y, meaning get y by itself. I'm going to rewrite it over here just so we have more workspace. Okay, so I spy on the right side a number times a set of parentheses, so we need to get that distributed through. Good, so 3/4 times x minus 3/4 times 2. Good, I see Caden working on his paper. Good, 6/4. Yep. And then we have y minus 1 still on the left side, right? Okay, so one more step to get y by itself. So we need to add 1 to both sides. I'm going to add 1 to negative 6/4. Negative 6/4 is negative 1.5. So negative 1.5 plus 1 is going to be a negative 1/2. Okay, so this is interesting. Our b, our y-intercept is negative 1/2. Is that what we thought it was when we looked originally? Did we think our b was at about negative 1/2? We did. We did. But we were unable to call just from the graph what it is. But we were able to actually verify using algebra by first using point slope form and then solving for y to put it in slope intercept form. We're actually able to verify what our y-intercept is. All right, you guys just look at the volume of work that you're doing here, analyzing. This is wonderful. Okay, what questions do you have for me on this slide? Okay, the next slide kind of, oh, okay. It's not what I thought it was, but that's okay. These are gonna help for your summative assessments. Let's see. Okay. Who wants to do 3? Any volunteers? Caden? Awesome. Thank you. Why am I purple all of a sudden? Better change it. Malachi's gonna get mad at me for using her color. Don't tell Malachi. Okay. All right, Caden, you're on 3. Malachi, you're on 5. All right, Katie, you are on quality control. Check them both. Dun, dun, dun. Oh, that's not helpful. Oh, that's not helpful. There we go. Okay, Katie, is that your green check down there?
Yeah.
Love it. All right, teacher Katie is verified. Good job, Malachi. Good, Caden, you're pulling out the important information. Yeah, really good job on that one, Malachi, keeping track of the negatives. Okay, Katie and Malachi, while Caden is working on that one, why don't you guys work together to solve 5? Find, what if the rest of the question was find the y-intercept? Ooh. What would you do on that one? Hey, Caden, I'm going to write in the bones of the equation for you. So you can just substitute in. There we go. Okay, Caden, there you go. Go ahead and substitute in what you know. So you know your slope. Caden, can you hear me? Yeah? Okay, what's your slope? They tell it to us. Oh, okay.
My slope would be -4.
Good.
4.
Good. Go ahead and throw it in right here. There's empty spots of the equation for you to substitute in your info.
So mx. I can't. This is where things get annoying. When you have this bar that shows everybody, you can't see anything
I
else.
know.
The people.
I
There we go.
know.
Now I can see. Okay.
I can write for you too. Let me know.
If this was slope, that means this would be -4.
Good.
And then I have a known point. Hey, who did that? Who's crossing off my stuff? I had that reason.
I don't know if they're crossing it off. There we go.
Thank you. I couldn't see my work.
Oh yeah, he's organizing. That's his X and that's his Y value. I totally get it. Okay.
Okay, so
Where?
that would be mine.
Good.
So that means we'd have to go minus 6.
All right. You guys down there finding your y-intercept. I see you're solving for y. Beautiful. Distributed.
And you have another minus. So if you have minus and minus, minus and minus, dragging that down. So we got this. I know this is for sure. All right, you have 6 and then 4 of a known point.
So what's your X coordinate of your coordinate pair that you know?
4.
Good. Good. So get that 4 in there. Beautiful. All right, Katie, teacher Katie, do you agree? Sorry to interrupt you on your work down there. Oh, but I love how you're writing that y-intercept as a coordinate pair. Beautiful work shown. All right, Katie, teacher Katie gave you a green check. POTB. All right, and teacher Fergus loves your work down there, Katie, with your distribution and then getting y by itself. Beautiful. Okay. It is almost time to go. So I'm going to stop going over. I know time flies when we're having fun doing math. If you want to go over any questions that we talked about in class or questions that you're going through on your own, feel free to stay in. We can go over some questions. Otherwise, it was wonderful seeing you, and we'll see you next week. Have no fun tomorrow on your day off. Goodbye.
Thank you.
Did you just say have no fun tomorrow?
Just have to make sure you guys are listening. Yep.
Okay.
Okay.
Hi.
Are you clear on what you're going to do to get unlocked in Apex?
I have to do this. Oh my goodness. I had this one test. It was a 3-point. I think it was the 3-point. It was one of the 3-point points or the beginning of unit 4, and I was doing it, and I got stuck, and I forgot to finish it up. So I went back to go and finish it, but I was still having trouble with it right then. And then and it was like it was a Monday, so like the next day I made sense. And so I went back to go do it after the Zoom, but I had used up my 3 tries, so I can't get past that because I need another try.
Okay. And so that's on your Apex, right?
Yes,
Or
that is
okay. So did you get, I sent your most recent quiz attempt in an email today? Hopefully I did. Did you get an email from me today?
I got an email that said that I need to use the Apex worksheets. But I didn't get my score. I never saw my score.
Okay. So I replied at 9:20 23, I'm looking at it right now. I sent you your quiz attempt that has all the questions and has what you picked and the possible answer choices. So I want you to go through that document, find the ones that were incorrect, and I want you to fix them
Okay.
by going through your worksheets if you need to, or the lesson again. And
Right.
your explanations for your right answers need to pass the mom test.
The mom test.
Yep, moms are everywhere. And then we'll move you forward. So once you show you know how to do those problems correctly, we'll just move you to the next lesson, okay?
Okay, because I remember I was like doing it, and I try and get the Apex stuff done really quickly. So I was like trying to catch up really quickly. So I'm like trying to catch up, and then I finally caught up, and now I'm behind again with Apex, and I'm like, Apex is not my thing.
Yeah. So
It's-
here's the Apex is like the most important part of this class though. So don't submit summative assessments until you've studied that work in Apex, okay? It's okay if you're behind, because if Apex is taking longer, that's fine, okay? But right now you're trying to live in two worlds. You're trying to stay up to pace with your summative assessments, but you haven't studied that work yet in Apex. So how are you, I mean, it's not your fault. You don't know how to do it because you didn't study it in Apex. So don't even submit it yet.
Okay.
Does that make sense? Okay.
Yes. Thank
Okay.
you.
Yeah. So work just double time on Apex until you get caught up.
Yay. Okay. I'll make
Yeah.
sure. I was like, and when you did the thing with the I was like, no school on Wednesday. How does that work? So I was really confused, and then I was like, oh, they just give you less work, and I'm starting like, okay, I think I can catch up on Apex this week, hopefully.
Cool. Yeah. So if you want to use some time tomorrow, that's a great use of time. Yeah.
So I think that's what I'm gonna do for tomorrow.
Love it.
Thank
And
you.
yeah, and don't kill yourself, because your brain is not effective after a couple hours of doing the same thing, right? So don't say, I'm going to work for 4 hours on Apex. That's not realistic, okay? Do like an hour, take a break. Do another hour, take a break, okay?
Yeah, I woke up this morning and I was like doing this typing thing, and it like gave me this thing, and it says recommendation. For every 20 minutes you work, you get a 20-second break. And I was like, okay.
Yeah.
I'll probably do that. Or it's like, and it was like, or every hour you work, like get up and do something.
Go do something.
And I was like, this kind of applies not to only typing, but kind of to basically everything.
Everything.
So that was
And I even take it one step further and say, go do a chore in between. I know. The common sense is astounding.
I know. Well, thank you.
Okay,
Bye.
good to see you. Bye. I'm done.